Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 6.1, rate of change and slope. The rate of change is the relationship between two quantities that are changing. Another way to think about that is, well, it's also known as the slope. It's pretty important. You're going to need to know about the slope for the rest of the year. So the rate of change, equals the change of the dependent variable over the change in the independent variable, also known as the rise over the run. Okay? So let's look at example number 1. We're going to use the table. Talking about running a computer here. So we have the number of days on the left, the charge on the right. Let's think about which one of those we could physically change. Can we change how much somebody's going to charge us to rent their computer, or just the number of days that we hold on to it? Well, obviously just the number of days. So that will be my x, or my independent variable. The charge will be my y, or my dependent variable. Okay? Let's check out the change. From 1 to 2, it would be plus 1. 2 to 3 would be plus 1. 3 to 4 would be plus 1. 4 to 5 would be plus 1. From 60 to 75 would be plus 15. Plus 15. Plus 15. Plus 15. Okay? Because every time I go up a day, it adds another $15 to my charge. For the data to the left, is the rate of change for each pair of consecutive days the same? Well, it's $15 increase in the charge per day. So yes, it would be the same. So we need to find the rate of change. Well, the change of our dependent is our y, so it's 15 over the change in our independent, or our x, so that's 1. So the rate of change will be 15. What does the rate of change represent in this case? It is the change per day, or a $15 increase per day. That is all the slope really is. It's just talking about the change in our dependent variable over the change in our independent variable. Okay? On to example number 2. This is using a graph. So we just figured out how to use a table. Now we want to figure out how to use a graph. The most important thing that you want to do when you have a graph is find some points that cross perfectly at an intersection. If they cross perfectly at an intersection, that means that I can actually figure out the x and y values. Well, my x's are always on the bottom, my y's are always on the side. So at this first point up here on the top left, it's going to be, my x will be 0, my y would be 800. Okay? For this point right here, the next point there, my x would be 1, my y would be 793. For the next point, my x would be 2, my y would be 786. For the next point, my x would be 3, and my y would be 779. Excuse me. And my last point, my x would be 4, and my y would be 772. I wouldn't necessarily have to mark all those points, but I just wanted you to get a feel for what I'm looking at, okay? So the graph at the left, I don't know why that says right, shows the number of gallons of water in a drought-ridden lake. We need to find the rate of change. So what we're going to do is we're going to take one of these points. We're going to look at 2 points. So I'm going to look at the 1, 793 and the 0, 800. Okay? So the change occurs from 0 to 1, right? So it's my change in y. So my it'd be my change. A little triangle like that means my change. So change in y over my change in x. So in order to find my change in y, I'm going to take 793 minus 800 over. To find my change in x, well, I'm looking at this point here and this point here. So it would be 1 minus 0. 793 minus 800 would get me negative 7 over 1 minus 0 would get me 1. So my rate of change is negative 7. Explain what this rate means. Well, it's talking about my y values are the volume in gallons. The x values are time in days. So if I have negative 7 for my change in y, that means that I'm losing 7 gallons per, what is my x value in? It's in days, so I'm losing 7 gallons per day. Okay? Let's go ahead and go to the back. What is slope again? Well, slope is rise over run, or my change in y over my change in x. Okay? So we're going to go ahead and use a graph to find the slope of each line. Again, we would need to make some points that cross at a perfect intersection. In this case, they already did that for us. But what I would like to do real quick is to make my coordinate. So my x would be negative 1, my y would be positive 1. So now I know that that point is negative 1, 1. This next point over here, my x would be 4, my y would be 3, so this point is 4, 3. From here, I know that I can subtract my second point from my first point in order to find my change in y and my change in x. So what I'm going to do is take 3 minus 1 over 4 minus negative 1, which would get me 2. 4 minus a negative is the same thing as adding, so it's 2 over 5. Now, there's another way I can do that without actually having to subtract. Don't worry about erasing this. I'm just going to show you something interesting. I can do this by counting the rise and then the run. So from this point to this point, how many points higher is that than this? Well, 1, 2. It's on this line here, right? And then how many points to the right is it from my original point? Well, so I counted up to, I can count right, 1, 2, 3, 4, 5. So again, 2 over 5. So on the next problem, instead of doing the math, let's just count. I'm going to start at this point here and move to this point here. Well, if it's going down, are my y numbers getting larger or smaller as I go down? They're getting smaller, which means that my rise is actually going to be negative. So I'm going to go down 1, 2, 3. So that would be negative 3 over. Then I go to the right, 1, 2, 3, 4, 5. Moving to the right will leave me with a positive number. If I were to move to the left, then I would have a negative number. So my change, 1, 2, 3, 4, 5. Yep. Okay. My slope in this case is negative 3 over 5. All right. Let's move on to example 4, using points. So the slope formula we've actually talked about a little bit. I just haven't given you the actual formula yet. It is our y value at our second point minus our y value at our first point over our x value at our second point minus our x value at the first point. So we need to find the slope of the line that passes through points negative 2, 1 and 6, 7. Remember that my second numbers are always my y. So I'm going to call this y1. I'm going to call this y2. Using my formula to get my numerator, I would take 7 minus 1. Okay? This is going to be my x1, and this is going to be my x2. So to get my denominator, it would be 6 minus negative 2. Well, 7 minus 1 would get me 6. 6 minus a negative is saying the same thing as 6 plus. So this would be 8. I can simplify that. They are both divisible by 2, so it would be 3 over 4. Now the other thing I want to tell you real quick is slope is characterized by the letter M. We always use M to say slope, okay? So we need to find the slope of the next line. Remember, M represents slope. 5 will be my y1. 7 will be my y2. 2 will be my x1. And 4 will be my x2, okay? So I'm going to take y2, 7, minus y1, which is 5, over x2, which is 4, minus x1, which is 2. So 7 minus 5 is 2. 4 minus 2 is 2. Both of those are divisible by 2, or you could just take 2 divided by 2, and I would end up with 1. Okay? So in that case, my slope would just be 1. All right? Moving on. Horizontal and vertical lines. In this case, we could either use our slope formula to figure out what the slope is, or we could just count the rise over the run. Well, the rise from this point to this point would be 0, over my run would be 1, 2, 3. So my slope, 0 divided by 3, I'm sorry, I forgot to put the m in there. I'm going to talk about my slope. My rise was 0, my run was 3. So 0 divided by 3 is just going to be 0, right? Okay? So in this case, what you need to realize is anytime I have a horizontal line, just like this one, the slope is always 0. Now, if I have a vertical line, so I'm going to go from this point to this point. My slope will equal, well, what's my rise? 1, 2, 3, 4. What's my run? It doesn't go right or left, so my run would still be 0. Go ahead, and if you have a calculator handy, go ahead and type in 4 divided by 0 and see what happens. What you're going to find out is that it's going to show up as an error because I cannot have a 0 in my denominator. So since I can't have a 0 in the denominator, this is known as undefined. You don't have to write the quotes around it whenever you give me the answer undefined. But anytime I have a vertical line, just like this one, the slope is undefined. Okay? So the summary. It wants to know about positive slopes. Well, the example up here, my slope was positive because it's positive 2 over positive 5. So what does my line look like? Well, it is going up as I go from left to right. So down here at positive slopes, I'm going to draw an arrow from left to right. It is going up. Okay? Negative slopes. It's asking us about negative slopes. Well, our second example over here, I have a negative slope, negative 3 over 5. And as you notice, as I move from left to right, it is going to be going down. So I'm going to take and draw an arrow down from left to right. Okay? Vertical lines, we just talked about that. Nope, not there. I'm sorry, that's a horizontal line. Vertical lines, we just talked about that right there. So its slope is always undefined. Okay? Horizontal lines, the slope is always 0. So that is the end of our lesson. Just remember the couple different ways that we can find slope. I can either count the vertical movement or my rise, and then take that over my horizontal movement or my run. Or I could take the y value from the second point minus the y value in the first point over the x value in the second point over the x value in the first point, and I will be able to find my slope. Also remember that the rate of change is also known as slope. So slope and rate of change are exactly the same thing. And again, it's my change of dependent over my change in independent. Remember, if you have any questions for me, go ahead and come in either before school or right before class starts. Thank you very much for watching the video, and have a great day.